So let's take a look at one like 59n. I will also note that this is very similar to number 53d. And of course, substitution method is going to be used in this. The problems in 59 are given to just work at being able to determine the technique, how to integrate a given function to find the antiderivative. And so some use substitution and some can be done without. This one really needs substitution. So let's take a look at it. So it's very similar to 59n. I've just changed some of the numbers around. But you have x minus 4 times the square root of 7 minus x. Now, there's no amount of algebraic manipulation you can do to simplify things. You can't just simply square. Okay, please don't just square this and say you can proceed. That would be like saying, well, I don't like to deal with the square root of 2, so I'll just square it, and I get 2. So the square root of 2 is equal to 2. No, you totally changed the problem by squaring. I can't like distribute through here, right? Because remember, square root really means what? This is really saying that 7 minus x to the 1/2 power. All right. So that is not going to be able, we're not going to be able to simplify this algebraically in any way. Okay, so how do we proceed? Well, substitution can simplify things. Hopefully that's the point of the substitution. So in a sense, it's an algebraic substitution, but we do have to worry about the dx here, the derivative part, as we look at it. And what do we typically choose the u to be? Look for a composition of 2 or more functions and let u be the inner function is a common theme. So that's one way to do this. It's not the only way, but it is certainly consistent with the way we've done things in the past. So I see the square root of 7 minus x. I see 7 minus x is the inner function, and the square root of u, or u to the 1/2, is the outer function. So I'm going to let u be 7 minus x. That's my substitution. Let's see if it gets us somewhere. Okay, let's try that again. With substitution, try something. See if you can make the integral simpler. Something that you can do by a substitution. If it's going to work, it should bring you to a point where you begin to see that the integral is going to be easier to determine. So let's see if that's the case. So first off, right away, you need to find the du, right? If I take the derivative of 7 minus x, I get -1. So du over dx is -1, or du is negative dx. Of course, I like to phrase it in terms of what the dx is equal to. So negative du is equal to dx. So I've got my dx taken care of. U is the square root of 7 minus x, so this will be u to the 1/2 power, or the square root of u. And then what about this x minus 4, though? I don't have an x minus 4 in my relationship between the du and dx. However, I can solve for x in this equation here that I started with, the substitution, right? By simply adding x and subtracting u, right? Adding x brings it over here. Subtracting u will give me x is 7 minus u. And now to get x minus 4, what do I need to do over here? Just subtract 4 from both sides. So x minus 4 is 7 minus 4, 3 minus u. So I just use algebraic techniques to get an equivalent statement. So x minus 4 in terms of my substitution is 3 minus u. Right? If I do 3 minus the quantity 7 minus x, I get x minus 4. Okay, so I now have x minus 4. I've got everything covered, and we can do and see what this brings us. So when I do this, the x minus 4 becomes a 3 minus u. The square root of 7 minus x, or the 7 minus x to the 1/2 power, becomes what? U to the 1/2 power, and the dx becomes the negative du. Okay, so I'm just substitute. Notice there's no x's here. That's real important. There's only u's. Now we simplify. I'm going to distribute here. This is a negative u to the 1/2 times 3 is negative 3u to the 1/2, and a negative u to the 1/2 times a negative u. Negative times negative is positive. U times u to the 1/2. Add the exponents, 1 plus 1/2. I get 3/2. So there's my function. Now look at this. Can you do this one? Yeah, this is simple. See, it's simpler after that substitution. If it didn't get simpler and clearer, then obviously maybe you've either made an error, hopefully not, but that could be the case, or you just need to try a different substitution, or a different technique. Okay, so the substitution should make it easier to do. So yeah, so just power rule, factor out the -3 here. U to the n is what? U to the n plus 1 divided by n plus 1. So dividing by 3/2 is the same as multiplying by 2/3. And then here, add 1 to 3/2 gives me 5/2. And so divided by 5/2 or times 2/5. So there's my antiderivative. Clean this up a little bit. -3 times 2/3, the 3's cancel. I just have -2. And I'll go ahead and replace u. Remember, u was what? 7 minus x. So I'll go back to the original variable, and I get -2, 7 minus x to 3/2, plus 2/5 u is 7 minus x to 5/2 plus our constant. There's our answer. Okay, there's one way of solving this problem. Okay, if that makes sense to you, I think it does, and that's consistent with the way we've done a lot of substitutions, then you're good to go. You've solved the problem. Okay. Now, is this the only way I could have solved this problem? No. Okay. You could be genius level or divine and be able to immediately look at this and know right away that there's the antiderivative. Just know it. Okay. That's not going to be the case. It's not going to be the case for me, not going to be the case for a lot of you. Okay, we're not just going to see that in general. So you've got to show the work. You got to show the supporting work in substitution, very important. But also it's not the only way. So if you're content with this explanation and it makes sense and you're good to go, stop the video and try the problem yourself. Okay, if not, I want to show you one other way. And that is, instead of choosing u to be 7 minus x, I'm going to do something different here and choose u to be the whole square root of 7 minus x. It's just a little bit different technique here that is going to work, and I'll show you what the difference is. First of all, what we're going to do, instead of finding du directly, because then if I take the derivative of the square root of 7 minus x, I've got a chain rule, right? This is 7 minus x to the 1/2 power. I'd have to bring the 1/2 down, 7 minus x to the -1/2 times the derivative of the integral, which is -1, blah, blah, blah. Instead, what I'm going to do is I'm going to square both sides. If this is my substitution, I know that u squared is just 7 minus x. Now I'm going to take the derivative implicitly, right? If I take the derivative with respect to x of both sides, what do I get? Well, here I get 2u, right? Derivative of the outer function, u squared, times the derivative of the inner function, du dx. So this is chain rule. Remember, u is a function of x. So when I differentiate this with respect to x, I get 2u times the derivative of the inner function, du over dx. What's the derivative of 7 minus x? Derivative of 7, a constant, is 0. Derivative of -x is -1. Okay, so there's the derivative. And if I multiply by dx both sides, I get 2u du is equal to -dx. And there's my dx part that I need. And so if I multiply both sides by -1, -2u du equals dx. Okay. Now, what about the x minus 4 part? Well, I can again do the same thing here and solve this part for x. Add x and subtract u squared. That gives me x is 7 minus u squared. Right. So add x, subtract u squared. And then to get x minus 4, which is what I want to get here, subtract 4 from both sides. Very similar to what we had before. X minus 4 equals what? 7 minus 4 is 3 minus u squared. So I've put in black boxes the important things that we need. And if I take those black boxes, you can see at the bottom here, if I get the original, here's the original integral, and just replace it. What's the x minus 4? The x minus 4 is 3 minus u squared. What's the square root of 7 minus x? Well, this times the square root of 7 minus x, the whole thing is just u. And then what's the dx? -2u du. Okay, clean this up. I got -2u times u is -2u squared. Distribute -2 times 3, -6u squared. And then the -2u squared times -u squared. Negative times negative is positive. 2u squared times u squared, u to the 4th. So there's cleaning it up. Now, one thing that's neat about this one compared to the other ones, remember the last one, we had these fractional exponents going on. Nothing wrong with them. In fact, both of these problems are essentially the same the way we do it. We're just going to use the power rule. It's just we don't have any fractions to deal with. Maybe a little cleaner. All right. What's the antiderivative of -6u squared? Well, the antiderivative of u squared is u cubed divided by 3. 3 goes into 6 2 times, so I'll get -2u cubed. Antiderivative of u to the 4th is 1/5 u to the 5th, right? 1/5 u to the 5th. 1/5 times 2 is 2/5 u to the 5th. And there it is, right? Just simple polynomial antiderivative. And now I can replace u. Remember what u was? U was the square root of 7 minus x. So I plug in that for u. I get the square root of 7 minus x cubed plus 2/5 square root of 7 minus x to the 5th. But what is the square root of 7 minus x cubed? This is what, to the 1/2 power, right? 7 minus x to the 1/2 power. 1/2 times 3 is what? 3/2 power. That's what 3/2 power means, by the way, right? Take the square root and then cube it. And then here, what? The square root and then to the 5th power is the 5/2 power. And if you look and see, go back to here at the bottom is what we had last time, identical, right? The same thing. So again, we get the same result. And so the little slightly different way of getting there. So there's not one way only to proceed. They're essentially the same way, really, because basically they're doing the same thing. And basically, if you could even see, the parts are very similar. And we just do a slightly different u substitution. So keep that in mind. If this helps better, you can do problems of this nature this way. But again, the bottom line is you've got to keep trying new things so that you observe that and take that in. Watching someone else do it every time and then trying to just on your own figure it out doesn't always work, right? So you want to make sure that you spend time and come up with some of these on your own and feel good about that, right? So that's what the point of number 59 is, with all these different integrals, trying to synthesize and put together all the techniques we've learned so far. And that'll be a common thing we do. As we go through the course later on, we'll stop at a point and just say, hey, let's look at everything we've learned and see if we can apply it to these integrals. Okay, so that's enough on this problem. It's a good one. I hope you enjoy working on it.